The first thing that we're going to need to do when using the vector class is, of course, include the vector header file, which I have already done up at the top here. So we are going to be able to clean up some of this code because we don't really need to ask the user how many elements they want to input again, although we might see some advantage to that. So I'm actually going to comment that out for now. So we'll just comment this out. Or actually, in order to keep this code around, we will use, we'll just turn it off and we'll kind of copy and paste it in. So instead of dynamically allocating our array and everything, we will put a block around this, which is going to turn this code off, right? We can see that it kind of went a little bit gray there. So this is going to happen at the preprocessor stage. So if 0, 0 is basically false, and that means that this code here, so from line 25, or well actually from line 26 to line 39, is not going to even be compiled. So as far as the compiler is concerned, this code just does not exist. So we don't have this input validation anymore for how many elements we want to input. We're not dynamically allocating this array. So some of this stuff is going to need to change a little bit. In fact, we'll just move this down so that we have a complete example for this, and we'll copy and paste what's relevant here. And we'll put a little comment up here that says that we're dealing with arrays, and then we'll say with this we're dealing with vectors. And we'll put this in a little block as well. That way we can turn on and turn off whatever we want. So if 1 or anything non-zero is going to evaluate to true, and that code will be valid. So let's go ahead and copy this input validation loop here. Let's basically copy all of this stuff. We'll make some changes and updates to that code because we won't use the same variable names. And let's create ourselves a little vector. Excuse me. So we'll create a vector of integers. We'll just call it vec. So remember from systems programming and even in C# when we were dealing with generic classes, or in C++ we call them template classes, they require a template argument, right? What type are we working with? In this case, what type do I want to store? I want to store integers. So we're going to make a vector that stores integers, and we'll just call it vec because that's just a generic name, right? So now we go into our input validation loop, the same thing we had before, and we're going to want to fill that in. So we are going to use, instead of the bracket operator, which is valid within the vector, so this will not work for now because we don't have any space in our vector, and we can demonstrate that here. I don't believe we have elements filled. I guess we do. Where is that at? Let's give this a compile. I'm not sure if that, yeah, elements filled is not a valid variable right now, so we'll go ahead and put that in up here just for, so that we can get a compiling program, right? And let's put in a value. Right, so this is going to crash even though the bracket operator works for a vector class. It only works once we've actually added something to that vector, and we can then either access or overwrite that value. So let's look at how we would actually change this around so that we could store a legit value with inside this vector. The most common way that we would add an element to a vector is by the method pushback. So let's go ahead and change this line here to be using the pushback method. push back, and we'll push back the user input value. Right. And actually, now that we're dealing with the vector, we don't need to use this elements filled variable anymore. So let's get rid of that. Internally within the vector, there is a method that we can call that lets us know how many elements are being used within the vector, and that is a method called size. We can still print things out using the bracket operator. So this operator has been overloaded within the vector class, much like we've overloaded the assignment operator to do the rule of 3. So this will still work. And we would also be able to overwrite valid elements within the vector if we wanted to, right? We crashed previously because there was nothing at index 0, but we would be able to overwrite index 0 after we had put a value in index 0 because there's now memory there. And if we haven't pushed anything into the vector, then there wouldn't be any memory allocated in that array as of yet. And we'll take a look at how that works here in just a moment. So let's verify that this works by putting in a few values. Okay, and we can see now that we're not crashing like we did in the previous version just a couple of minutes ago, and the program exits cleanly. Okay, so now let's take a look at what happens with the memory inside of the vector. How am I able to add things pretty much infinitely? In order to demonstrate this, we're going to go to a slightly different little example here. So we're going to turn off this code. So all of this stuff that we just wrote is going to get grayed out there. And we're going to look at, let's say, vector sizing. We'll make another little block here that we can turn on and turn off. So when you're going through this example code, when you want to test something, you can just change something to a 1, and it will run through that block of code, right? So we'll go ahead and, just so that we can do things one at a time, let's put that user input in both of these so that we can do that. So here we're going to look at, we'll create another vector. We'll just call it vec again. So if you do turn on or want to turn on multiples of these examples simultaneously, you will run into some naming conflicts. So keep that in mind. You may want to go through and change some of these names, or just remember that you can only run one at a time. So in the previous little example that we did, we saw that we have a size method that's going to return the number of elements that are currently being used in the vector, but that's not necessarily the number of elements that we can fill in. So what we're going to do here is just do a couple of little printouts. So I'm going to see what the size is, and then there is another data member that lets us know our capacity. And of course, that method name is capacity. So this could be, we could relate this to the original example we used where I created an array of 10. So that would mean that our capacity was 10, but our size would be that elements filled variable that I created, right? So I have the capacity to store 10 values, but I may only be storing 3 or 5 or whatever. So now let's go through and add some values in here, just kind of randomly. So we'll loop 100 times here, and we'll just push back some random value. Doesn't really matter, we're not going to use them. but we'll just push back a random number between 0 and 999, and then we'll print this same message again. Okay? So now, let's go ahead and run this and see what happens. We're going to get quite a bit of output here. So if we scroll all the way up to the top, right, before I entered into my loop, I have a size of 0, so I'm not storing anything in my vector, and that vector has not been allocated yet. So it has a capacity of 0. Once I start adding in data, the size of the vector is going to increase. And as we scroll through here, right, we can see it's not increasing. Well, it is increasing at a consistent rate, but it's not something that we can immediately tell what that rate of growth is. For this implementation in Visual Studio, we're looking at a growth rate of 1.5. So if we take every time that it resizes, it's resizing by a multiple of 1.5. So that's going to be a very small growth in the beginning, but then as we get into larger sizes, then the capacity is going to increase larger. And the reason that it's doing that, rather than increasing by a growth rate of just 1, is because it doesn't want to have to resize that array every time we add a single piece of data. That resizing procedure is a little bit expensive, and we're going to talk more about that in the Dynarray lecture, which is next. So we can see ultimately when we get down to the bottom that after I've added in 100 elements, we're able to store 141. So I could keep adding another 41 elements and not have to have the vector resize that array again, right? So it does this resizing procedure so that we can not have to worry about a fixed size. So this is going to be really great when we have to store a bunch of data and we don't necessarily know at compile time what that value is, right? How many things I need to store, or even that I may need to store more data as the program continues on, as users input more data or we get more input from various files or what have you.